Hello, and you're very welcome. I have the privilege of being in conversation over the next 30 minutes or so with Dr. Brian Kelleher. And Brian is going to speak to us about CK408. And CK408 is physics and astrophysics. Brian, there's an awful lot of people really interested to hear what happens when you study physics and astrophysics at UCC. Lovely to meet you, and thank you for joining me.
And you, thanks for the opportunity to promote the programs.
So tell us, what is CK408?
Well, CK408 is, as you said, our physics and astrophysics program. So this, there are several streams, but I guess we can talk about things like this later within it. But in general, what you are getting is a background in physics. And this is really aimed at people who like physics, in my opinion. The number one reason that you would choose to do CK408 is because you like physics.
And do you have to do physics in school?
You don't actually have to do physics in school to do it. You need to do honours maths, and you need to get a minimum of a H4 in honours maths.
Okay.
But we actually just treat everybody coming in as if they've never done physics. And you start off at the beginning, so it's open for people from that point of view. Applied maths is quite rare, in fairness, for people to do in schools. It's not offered in very many schools at all, but by any chance, if someone does applied maths, this is very much a good indication of the type of thing you'd be doing in UCC if you did CK408.
And how long is the degree?
The degree is 4 years.
So when you come in first year, is there a prescribed list of subjects you must do, or do students already have choices?
There are choices straight away in first year. So when you come in, there are 3 options. So option 1, option 2, and option 3, imaginatively titled. And some of the main differences between them is simply the maths modules that you'll take. So everybody will do the same physics modules. And then there will be some, so option 1 will be for people who are quite certain that they want to do single honours physics. So you want to study physics or you want to study astrophysics. Option 2 is for people who think that, you know, they might also be really interested in doing some maths as well. Now it's unavoidable. You will have to do maths and applied maths modules as part of the program, regardless of the option you choose. But if you think you might like to do joint honours program, which is where you do 50% maths and 50% physics, then you take what's called option 2. So it has some more kind of abstract mathematical modules. And then option 3 is for people who'd like to pursue science education.
And where does the astrophysics come in?
Astrophysics doesn't really begin until 3rd year. So in 1st year and 2nd year, the astrophysics students and the physics students are essentially identical. And then in year 3, you choose to continue with astrophysics, and then you start to have some modules that you must take. They become mandatory, all the astrophysics type modules, studies of stars, of the galaxies, things like advanced courses in gravity. But all those modules are actually available to the people who don't pursue the astrophysics degree as well. They're just not mandatory. They're elective subjects that they can choose to take if they so desire.
So do you graduate with a BSc in physics and/or astrophysics?
Yep, so you get either the BSc in physics or the BSc in astrophysics.
Okay. And if you decide to take the astrophysics route, what kind of, apart from a genuine interest in the galaxy and the physics, the mathematical alliances up there, why else would you take that degree? Where would it lead you?
Well, some people just love astrophysics. I mean, you can imagine, right? Lots of people who are into physics, the thing that made them interested in physics first was things like astrophysics and the study of the galaxies and the stars and cosmology and the universe as a whole and black holes and so on. And then for some people, when they come in, they find actually, you know, I do love astrophysics still, but I also love all these other modules, and I'm not going to specialize in astrophysics. But some people, of course, the astrophysics, the love of astrophysics continues right through, and they want to have their degree say that it's in astrophysics. But actually, from a lot of practical points of view, I would see the two as equivalent. There aren't that many options you would close or open by doing one or the other.
I understand.
The same kind of prospects are there for both, I would say.
And talk to us about the prospects.
If you have a degree in physics, every employer wants to talk to you. So, you know, there are obviously very specific skills that you will get, and physics modules that you'll study and maths modules that you'll study. But there are some golden skills that you really pick up that are the things that we really try to develop in all the students. And these are things like the ability to think independently, to really be able to analyze a problem and solve a problem with analytical thought processes, how to analyze data, and lots of computation and IT skills. And in the end, then all employers really value these kind of things, particularly the independent thinking and the problem solving. And if you look at the types of employers who employ physicists in Ireland or internationally, the range is unbelievable. And even if I were talking about people who graduated in my class or near my class, some people like me continued on into academia and we became lecturers and researchers. Some people became teachers, and these are the kind of two things that everybody probably thinks first. Well, I'm going to be a teacher or lecturer, but actually there were people who went off and worked in semiconductor technology, so working for Intel, or people who went and worked for Apple, people who worked for PricewaterhouseCoopers and became management consultancy people in software development. Person in the year ahead of me became a lawyer, following his physics degree. People becoming mobile phone engineers, people working for Met Éireann. The range is absolutely incredible if you look at it, even especially these days. The data analytics skills that you get are in huge demand. So companies like Accenture come in every year to our fourth years and speak to them and try to promote their own graduate programs. People are increasingly going to work in places like Google and so on. So really, there's an unlimited range almost of employers who value the skills that you get in a physics degree.
So therefore, to talk to you about, we'd say, curricular employability skills, so employability skills that they acquire in the curriculum. You spoke about problem solving and critical thinking, and all those things, of course, are very, very relevant to the workplace, the world-ready and work-ready graduates. But are there specific, in addition, employability skills that you incorporate into the curriculum? Or do the students acquire those co-curricularly or extracurricularly?
During the year, we have regular seminars where people will come in, and lots of the times these will be academic or research type seminars. But a lot of the time, these could also be employers who are coming in to promote their company or talk about how they went from a physics degree to working for such and such a company. So you get things like that. But really specific employability modules or anything, not so much, I must admit.
Now, however, we do know that the students can participate in any clubs and societies outside of their degree, and some of the clubs or societies might be particularly relevant to those who have a leaning towards physics.
Yeah, no doubt. And in fact, we have a society, the Physics and Astronomy Society, which is extremely popular and active at the moment. And
the Graduates Attributes program as well is available, for students themselves to elect to take modules or to pursue opportunities. So I think there's probably opportunities for employability.
There is. And in fact, one of the things that we encourage a lot actually within for our later year students, let's say our third years and fourth years, is they can actually get involved in teaching. So they can either be teaching in a lab, for example, being the chief demonstrator for a set of experiments for first years, let's say. And that would involve then being in the lab and guiding them through the work and correcting it later. So we do peer assisted learning where second and third years, more so than fourth years even in this case, but also fourth years, will meet first years who maybe haven't done physics at all before. And they'll meet them in small groups, maybe 6 of those students who are coming in, never having seen anything to do with physics at all before, and maybe are a bit daunted, and they'll meet them in these small groups and take them through it. So they get a lot of nice skills in that of, responsibility and so on.
I agree. And I think that peer-to-peer learning is a great mechanism. And I think also, just as you mentioned it is courageous of individuals to consider pursuing a degree in physics who haven't done physics before, but obviously passion for anything will bring you a long way.
And of course, this would go as well for, say, many people who come in to do other programs within the university. They might not be studying for a physics degree, but they still have to do physics.
That's right.
So, even for somebody, maybe somebody came in to do environmental science, or maybe they came in to do biochemistry that came in to do engineering, and maybe physics itself wasn't the thing for them, but they must do physics. So for them, I think it's really helpful to have these people who've just been through first year and can help them out and kind of show them the ropes and so on, and take them through. Another thing I think is quite valuable is as you progress through the program, the responsibility on yourself grows. Of course, that must be true in all programs, I'm sure. But say in first year, you go and you do labs. It's a very important part. Of course, you have to do a lot of theory and you have to do a lot of experiments in our program. But, when you come into first year, you don't really know anything about the lab. So you need the demonstrators there. They have to show you everything. They have to really help you through it all. And then in second year, that's a bit true as well. You're getting a bit more. But then in third year and fourth year, we really encourage them to almost do the labs on their own. So there are still sessions where there will be a demonstrator who's there if you need them. But you're free to do the experiments on your own and in your own time. And that encourages independence quite a lot, and is a big part of the process of becoming an independent thinker and a problem solver in your own right, I think.
And we encourage independent thinking, a traditional independent thinking. But and also from my own perspective, I did biological and chemical sciences, what is now biological and chemical sciences, about 100 years ago. And I did physics in first year, but I can still really, really remember the practicals. There's something about the practicals in physics that just stick with you. They're presented in an enjoyable way back then, and I'm sure it's the same today, if not even better, but they stick with you and you remember the principles.
Yeah.
So if you think about the research-led teaching, what areas of research would the School of Physics or Department of Physics, Department of Physics focus on in UCC? In other words, what's the unique selling point of physics in UCC?
There are a few departmental specialties. One of them is photonics, which is the study of light and how you might use light in order to benefit life in general. So the name comes from, to be similar to electronics, but instead you're using photons, which are light particles, in order to do things. And there's quite a few of us in the department who are researchers in photonics. And a lot of us, that means we're studying a lot of the time lasers. And of course, lasers are absolutely everywhere in the world, from surgery, eye surgery, to going into the supermarket to scan through the things you're buying, or in your phone, or if you've ever using the internet like we are now, this is relying a lot on lasers. And several of us are researchers in photonics, and we are kind of almost co-located in our research between the department and Tyndall National Institute. So Tyndall National Institute is semi-autonomous. I say it's really part of UCC, but it's also its own entity in some sense. For people who don't know it, it's between UCC and the city centre, so it's just a few hundred meters towards the Cork city centre. And Tyndall is a really cutting edge place, really high profile researchers across a number of fields, amazing facilities and so on. And there's a very strong link between Tyndall and the physics department. So that's a really strong point for the department, and it opens up things like, your final year project, for example. Many students will end up doing that down in Tyndall. Some of them in our groups, and some of them with affiliated groups who might not be strictly employed by the department, but are very strongly affiliated with the department. And it's a really amazing opportunity for people to...
I think there's no doubt that the Tyndall National Institute would be probably the biggest research institute in Ireland, and probably the one most globally connected. So I think we're very privileged to have, the Tyndall is, hand in glove with UCC, is a UCC research institute, and therefore for the students of physics to enter through the physics route, and then because you can also enter through the engineering route and find your way to Tyndall, and through different, not just.
Through lots of different areas as well, that's true, yeah. And then we have other researchers, of course, working, so astronomy, astrophysics is quite prominent, and you would guess it considering we have a BSc in astrophysics. And there's several researchers and professors in the department who are very high profile astrophysics researchers. And something that's really growing at the moment is quantum technology. So this is something that's even pervading into general media and so on, through quantum computers, and how we can use quantum physics, which is the physics of very small things, in order to benefit the world at large. And that's really growing within the department, because we have people who are straddling several different kind of areas. So people who are doing like laser spectroscopy, so again working with lasers, but they mightn't really consider it to be photonics, but it's where they're using lasers to study things like atmospheric physics, for sensors, so that using lasers in order to have sensors maybe in an industrial setting where it's important if there's going to be volatile gases released, that maybe you have some sensor that can alert you quickly that there's a problem on the factory floor. So, very important, both fundamental and applied type of aspects.
And in preparation for this conversation with you, I noticed chemical physics. Talk to me about that.
Yeah, that's another one of our possible streams that you can go to from entering through CK408. So naturally, as you would expect, people who are interested in physics are also often interested in chemistry. So there can be a student who comes in following school who really liked chemistry and really liked physics. Well, this is a way of combining both of those. So you come in as usual into CK408 at the physics and astrophysics program. And then there are some modules you must take in first year. You must take certain chemistry modules, of course. And then in second year on, you more or less have a 50-50 split between chemistry modules and physics modules.
So I can fully understand. So you end up with a degree in chemical physics.
Mm-hmm.
So you'll have modules of chemistry and modules of physics. With that degree, where would you find employment? Who's looking for the chemical physicists?
I mean, clearly, lots of the same skills will arise again that I keep talking about, the problem solving and independent thinking and so on. But then there are some specific skills, that you're learning by doing something with chemistry rather than only with physics. And that does open up opportunities in other areas. So maybe, for pharmaceutical industries, for example, might be more interested in having somebody who also has a background in chemistry.
Yeah. I could imagine things like the structure of compounds, for example.
Absolutely.
Yeah.
I mean, the distinction becomes almost meaningless at some level eventually, that somebody who's working in physics as a physicist can easily be looking at the structure of matter, which of course is something that you would also associate that a chemist would be doing. But it's really there, and it's been quite popular now. That and what I should say as well is that it also works if you come in through CK406. So probably my colleagues, if you've spoken to CK406, might have mentioned it as well. This is coming in to do chemical sciences, that you can then choose to do some physics modules in first year and then do chemical physics in second, third and fourth year.
So I think what is clear from the conversation that we're having in relation to CK408 is that if you have an interest in physics, even if you've never studied it, had the opportunity in school before you come to university, or if you're an adult learner in your life to date, you can still, if you have that curiosity, you can still pursue several options and take physics. And as you said, when you explore the prospectus, you'd see what else you could do. What plays to your strengths? Will I align my physics with astrophysics? Will I align it with chemistry? Or I do know that you offer another degree in the whole area of industrial physics.
Yeah. And also, as I said earlier, the joint honours with maths. So people who are just as interested in maths as they are in physics, they can do 50% of their time in the School of Maths and 50% in physics.
It's interesting listening to there, Brian, where the realization that physics is such a basic science which applies to actually everything that we know and use, whereas somebody who wouldn't know a whole lot about physics might think it's a thing apart.
Yeah, but
actually
absolutely everywhere. I drive my family mad with this, my children, when they say, well, sure, everything is physics. And, I'm sold, is chocolate physics? Yeah. Is a rabbit physics? Sure, why not? But it really is just cuts across absolutely everything.
Yeah. And just before we conclude, it's been very, very interesting talking to you about this. And I hope at another occasion, I might be able to speak to you about industrial physics, which is actually it's a different degree also offered. But we might have a chat about that now later. Do you want to dispel any myths about physics or the career of being a physicist?
Yeah, the one that I kind of already alluded to earlier, this kind of myth that you have, is somehow it seems to be very pervasive in Ireland that if you do physics, well, I mean, what kind of job are you going to get at the end? Mm-hmm. You find that this doesn't happen at all. Some of my colleagues who've come from Germany are saying, why am I getting this question at an open day? I get whatever job I want. I'm a physicist. So the idea that, you can only become an academic or you can only become a teacher, and they're the only two almost things that are available to you, when in fact, couldn't be further from the truth. Really, if you enjoy physics and you study physics, the job takes care of itself at the end, always.
Well, I think to study physics, as you kind of said at the beginning of the conversation, it's driven by a passion and an interest. And that's the basis of, as you said, the world opens up when you're driven by that type of interest. So for those who have an interest in coming to University College Cork and studying physics and astrophysics, they can look forward to being lectured from you, Brian, and they can look to the prospectus and find out more about studying physics. So thank you very much. It's been a pleasure having this conversation with you.
Likewise.
Take care. Bye-bye.
Employability and career development initiatives are delivered through curricular, co-curricular and extracurricular activities. Over 90% of our programs offer placements internationally and nationally. Throughout your time in UCC, you will have the opportunity to develop employability skills through entrepreneurship modules, skill sessions, and memberships of clubs, societies, becoming a class representative, and getting involved. Throughout your student journey, UCC Career Services will support your career planning with one-to-one career consultations and coaching. The Career Services collaborate with academic departments and other UCC units to deliver bespoke and standalone employability and career-related workshops and events for all students and recent graduates. Our annual recruitment fair is one of the largest national career fairs, featuring up to 100 top graduate employers. For more information about UCC employability initiatives and the career services, visit ucc.ie/careers.